Hey guys, what's good? It's Jeremy from the Chemistry, and today we're going to be looking at the periodic table of elements. Now, the periodic table of elements is the way that we have arranged pure chemical substances, which we know as elements. And the way that we've done that is based on their atomic number. See, it's arranged so that elements are placed in ascending atomic number. That's their order. You look at line 2, you see lithium with 3, beryllium with 4, then boron with 5, carbon with 6, nitrogen with 7, and so on and so forth. And the atomic number is simply just the number of protons that are present within the nucleus. Now, the number of protons present in the nucleus is also equivalent to the number of electrons that are present orbiting the nucleus. As such, your arrangement and where you fall as an element in the periodic table of elements says quite a lot about your chemical properties. Now, there are 18 vertical columns, but at the introductory level we focus on 8 of them as we group groups 3 to 12 into the transition metals. Now, down the group, each element has one more electron shell than the one above it. However, they all have, in each group, all the elements have the same number of outer shell electrons, which we know as valence electrons. Let's look at lithium in group 1, followed by sodium, which is right beneath it. Lithium has 2 electron shells, but sodium has 3 electron shells. However, both sodium and lithium have 1 electron in their outermost valence shell. Down the group, elements behave similarly, and that's why they're grouped together so well. Group 1 elements form the alkali metals, group 2 elements form the alkali earth metals, group 7 form the halogens, and group 8 elements form the noble gases, for instance. These elements in the same groups behave similarly, and the reason for this is because they have a similar electronic structure with special reference to the way how electrons are arranged in their outermost electron shell. Let us look at the elements in group A, being helium and neon. Helium has a full valence shell, and so does neon. And so these elements form stable atoms which are resistant to reaction under normal conditions. Then, when we look at our same group 1 elements from before, being sodium and lithium, we see that they both have 1 electron in their outermost valence electron shell. And we expect, therefore, for them to behave and react similarly. And that's why both sodium and lithium are well-known metals.